Bismillah ar-Rahman ar-Rahim. Our lesson today about U-shaped tube. First question. The relative density of a liquid can be determined using what is the function of the U-shaped tube at the first? Determine the relative density of a liquid immeasurable with water. Determine the density of a liquid with unknown 1. Then the relative density can be determined by using the U-shaped tube. The relative density of kerosene can be determined using the U-shaped tube from the relation. First, the relation using the U-shaped tube is rho kerosene, H kerosene equal rho water, H water. Then by making the ratio, rho kerosene divided rho water equal H water divided by H kerosene. The equilibrium state of two non-mixing liquids in the open U-shaped tube is known by the figure, at which level must the pressure be the same in both sides of the U-shaped tube. At which level? H1 within H2 or H3? At H1, because all the points that lie at the same horizontal plane of the same liquid acted by equal pressure. Then the correct answer is H1. The opposite figure shows the number of connected vessels that contain a liquid of density rho. If the pressure of the liquid at the point Y is P, then the pressure of the liquid at point X is. The total pressure is H. Then the difference between the pressure is 2 over 5 H. Then the pressure is 2 over 5 P. The opposite figure represents a U-shaped tube of uniform cross-section area filled with two immiscible liquids of density rho 1 and rho 2. If the liquid of interface lies 2 cm above the base, then the relation between rho 1 and rho 2 at the first. All the points that lie on the same horizontal plane of the same liquid acted by equal pressure. Then all the points that have the same height have the same pressure. This means that they are the same density. Since they have the same height, so the liquid on the right side have the same density of the liquid on the left side. Then rho 1 equal rho 2. Water is filled in a U-shaped tube of different cross-section areas on the two sides as shown in the figure. If equal amount of oil are poured in the two sides, the level of water in the narrow side of the tube will. At the first, this is the U-shaped tube of different cross-section area. When pouring amount of oil, equal amount of oil in the two U-shaped tube, the oil take a height more than in the narrow tube, more than the wide tube, because the area is inversely proportional to the height. And the pressure also is directly proportional to the height. Then the pressure of the liquid doesn't depend on the cross-section area, but depends on the height, where the pressure is directly proportional to the height. Since in H1 more than H2, then the pressure in the narrow side is more than the pressure in the wide side. So the level of water in the narrow tube will be lower than the pressure of the height of water in the wide tube. U-shaped tube contains the amount of water of density 10 power 3 kilogram per cubic meter. Then an amount of oil of density 875 kilogram per cubic meter is poured in one of its arms. If the height of oil column above the interface with water becomes 10 centimeter, so the height of water in the column which balances the oil column is. At the first, this is the U-shaped tube that filled with amount of water. Then amount of oil is poured and water increase in the other side. If the oil decrease the level of water H, then the height of water increase H. Then this is the separating surface. Since in raw oil H oil equal raw water H water, then the density of oil times the height equal the density of water times height of water, then the height of water is 8.75 centimeter. The opposite figure shows two liquids X and Y, which are at an equilibrium state in the U-shaped tube. So the ratio between the densities of the two liquids, rho X divided by rho Y is, at the first, the relation, since the pressure doesn't affect by the cross-section area, but depends on the height, then rho X divided by rho Y equal HY divided by H of X. From the figure, the height of y is 5h and the height of x is 2h. Then the ratio is 5 over 2. The opposite figure shows the U-shaped tube contains water and another liquid in a state of equilibrium. So the relative density of this liquid is, from the relation, relative density equal rho liquid divided by rho water, that is equal h water divided by h of liquid. From the figure, the height of liquid, the height of water is h, and the height of the liquid is 1.5 h, then equal to over 3. U-shaped tube of uniform cross-section area contains amount of water. Then oil is added to one of its R. If the relative density of oil is 0.8 and the height difference between the upper surfaces of water and oil is, at the first, this is the level of water, the level of oil above the surface of water. The height difference between them, then the question means H. What is the value of H? Let's say this is the separating surface. This is the difference between the surface of water and the surface of oil. Since relative density equal H water divided by H oil, then 0.5 H oil equal H water. The height of oil here equal H water plus H, the height difference. Then 0.H water times 0.8 H equal H water. Then the height difference equal 0.2 height of water. Then the height equal 0.2 divided by 8, that is equal 1 over 4. In the opposite figure, the ratio between the densities of rho A over rho P is, since rho A over rho P equal HP over HA, then 2H divided by H. Then the ratio is 2 to 1. In the opposite figure, U-shaped tube contains three different liquids in equilibrium. So the height of mercury, H of mercury, above the level of interface between water and mercury is nearly equal to, at the first, the pressure on the left side equal to the pressure on the right side, then rho H of mercury equal rho H of water plus rho H of oil. Then, by substituting the number in the relation, then the height of mercury is 2.35 centimeter. U-shaped tube of uniform cross-section area has two arms, each of length 20 centimeter. The U-shaped tube is placed vertically and filled to its half with water. Then the oil is poured in one of its arms to reach the end of the tube. If the density of water and the density of oil are, so the height of oil above the interface or the separating surface is. This is the U-shaped tube that contains uh, water. The U-shaped tube of height 20 centimeter. Oil is poured to decrease the level of water, for example H, and the height of water increase in the other side H. Then the height of water is 2H. Raw water H water equal raw oil H oil. Then the density of water times 2H, the total height of water, equal 800 times 10 plus H. Then the height is 6.67 centimeter. This is H only. Then the height of oil is 10 plus H. The height of oil equal 10 plus H. So the height is 16.67 centimeter. U-shaped tube of uniform cross-section area contains mercury. Amount of glycerin is added in one of its arms. If the height of glycerin above the interface with mercury is 10 centimeter and the cross-section area of the tube is 5 centimeter, so the mass of water which is required to pour in the other arm to make the surface of mercury in both arms is the same. At the first, this is the U-shaped tube that contains mercury. Glycerin is poured. What is the amount of water to make the level of mercury equal at the both sides? So this is the separating surface. The height of glycerin is 10 centimeter. Then what is the height of oil? So the height of oil equal 12.5. To find the mass equal raw volume, and the volume equal AH, area times height. So the mass of water equal the density of water times the area, 5 times 10 power negative 4 to convert it from centimeter square to meter square, 12.5 times 10 power negative 2 to convert it from centimeter to meter. Then the mass equal 0.0625. U-shaped tube of uniform cross-section area contains amount of mercury when the difference of amount of water is added in each. The liquid became in equilibrium state as in the opposite figure. So the height of mercury in one arm above the level of interface between water and the mercury in the other arm equal. First, this is the height of water, and this is the height above the surface of water. At the other arm, this is the height of mercury H, and this is the height of water. Let's compare between the two heights. This is the height above the water surface. This is the separating surface. From this separating surface, raw mercury, this is the height. Raw water, H water on the right arm equal raw water, H water on the left arm plus raw mercury, H mercury on the left arm. Then the height of water in the right arm equal 12.6 plus the height of water, that is equal the height of water in the other side, plus H. This is the total height of water. 3 levels. H plus H1 plus 12.6. On the left arm, the height of the level of water, H1 times the raw mercury, H mercury. By substituting the numbers, 1000 H water 1 cancelled with 1000 H water 1. Then move 1000 H in the other side by the negative sign. Then then the height is 1 centimeter. The opposite figure shows U-shaped tube contains two liquids. So the pressure at the point A equal how many to the pressure at the point B? This is the 2 points A and B. This is the separating surface between the 2 points. Here is H and here is H, and the pressure depends on the height. Pressure is directly proportional to the height. So high liquid surface, more pressure, low liquid surface, low pressure. Then the pressure at point A is less than the pressure at the point B.